right? So we'll discuss some of the fundamentals and then actually we'll proceed on to the mesh analysis and the nodal analysis. So before that, actually, we'll talk about some of the basic quantities that we have to be aware of before even going further on to the network analysis, right? So that is actually in the case of alternating current. So AC current actually, this is AC current. In the case of alternating current, there are certain terminologies like the average value and RMS value. So peak value, or this is maximum value. Right? So form factor, peak factor. So these are all the some of the basic terminologies actually that we are going to use in the case of the alternating current circuits. So these are actually general to any kind of waveform. So because actually initially we start learning with the help of the DC circuits, where the DC battery is actually specified with only one magnitude of the voltage. That is, suppose actually if this is the voltage that was specified for DC and this value is maintained constant throughout the time. That means if you try to draw the graph of the time versus the voltage magnitude, if you try to draw the graph, this is maintained a constant value V is equal to V naught given by this particular one. So this is V is equal to V naught, which is maintained constant. Now what if I give a voltage which is of completely variable? So that variable voltage is maybe a sinusoidal waveform like this. So this sinusoidal waveform, so if you try to draw the graph of time and the waveform, the voltage, this V value actually is continuously changing as if like it is a sine. So this is V is equal to Vm sine theta. So this is the waveform actually that is going to be given in the case of the sinusoidal waveform. Suppose if you give a step wave, so step wave is actually exactly the same thing. And you can even give a sawtooth waveform. So sawtooth waveform is this way. So there is actually, it will be continuously rising for certain time and then actually it is falling down suddenly. And this is what is called as the sawtooth waveform. This is still be a periodic waveform, but it is varied in such a manner that actually it is rising in a linear fashion and then suddenly drops out and again actually it goes. Now, other than this DC voltage, if at all you give any other kind of waveform, and that waveform actually maybe of a triangular waveform or maybe of a sawtooth waveform, maybe of a step waveform or maybe a ramp waveform or maybe a sinusoidal waveform. In all the cases actually, these values actually we do calculate it. The reason being, we know everything about the DC analysis. Everything about the DC analysis meaning, so we know actually how to calculate the voltage magnitude, we know how to calculate the current magnitude, and we know how to calculate the power magnitude. So as we are very well aware of the DC analysis, so whenever we want to deal with alternating current, so maybe of all these kind of waveforms, whatever it may be. Now in all such cases, actually, we will try to compare the quantities with the DC so that actually we will be easily analyzing, or actually at least we will get an idea what is the impact of it, right? So for that actually we have defined all these values which are not present in the case of the DC analysis, and these are present only if there is a waveform which is not of DC or which is not a constant value. So in all such cases actually we will be dealing with all these values. Now in this actually, now see this actually what is average value? So average value, and this is the DC equivalent of a time varying waveform is called average value. So the DC equivalent meaning, now actually if I say that 5 volts, then actually you know what is 5 volts. Meaning if you try to draw the graph of a 5 volts, so this is maintained at 5 volts whatever maybe the time it is going to be. Now actually if I say a sinusoidal waveform is given in this manner, then actually in this what magnitude I need to say. So let us say this is of having a height of 10 and this is having a height of 0. And this value is somewhere in between, and here actually again it is 0, and actually it is in the negative direction of -10, and then actually this way actually it is continuously changing, it is not maintaining a constant value like a DC. Now actually what is the equivalent of DC if I ask, then actually you need to come up with certain number. What is the impact of this particular 5 volts is giving on the circuit? Is it exactly the same thing it is going to give it? It may or it may not, right? Now actually we have to be talking about, there is something called the DC equivalent value of the AC, and this is what is called as the average value. So we need to be finding out the average of this particular waveform. Now here actually, from here to here actually this is a one waveform, and this process actually continues again. Now actually from here to here actually it is the same value. If it is, then actually you can assure that actually the same value is maintained throughout. So you wanted to identify a fixed value or a constant value out of this particular waveform, and then actually you wanted to say that is the equivalent of this particular DC. Now here actually in the case of alternating current, if I give to any particular circuit, so this is actually alternating waveform which was given to a circuit. Now during the positive half cycle actually it is passing through the current in this way. During the negative half cycle actually it will pass the current in the opposite direction, but it will exactly have the same effect in the forward direction and the negative direction. So but actually in the opposite direction, but it will have the same effect. So if you try to find out the average value of this particular complete cycle, and that actually it will come out to be 0. So the average value in this particular case is going to be of 0, because actually you know that actually if you try to calculate, that is V is equal to Vm sin theta, and this is the waveform. And if you want to calculate the average, so average meaning, so this entire area divided by the period, so that is what we call as the average value. How it is going to be? See this actually, if you want to calculate the area of this and this area, right? So the area actually whenever we calculate, so let us say this is V into d theta. So V into d theta, where V is equal to Vm sin theta, integral if you calculate it, so this will give the entire area, because actually V is equal to Vm sin theta. This is the curve equation, sin theta. Now this curve equation, if you integrate over a range of 0 to 2 pi, then actually it is going to give the entire area. Now out of the area is always a product of two different lengths. If you divide with one length, then actually it is going to be of 1 by 2 pi. If you calculate it, then this is what is called as the average. So this is what is called as the average. And this is applicable for all the kinds of waveforms, whether it is a sinusoidal waveform or a triangular waveform or a sawtooth waveform, it doesn't matter. In all the cases actually it will be exactly the same method what we are going to do to calculate the average value. But by looking at this waveform actually we can conclude that the average value of this complete cycle is going to be of 0, because this is a positive area and this is a negative area. So this positive area and negative area, if you add it together, it is coming out to be 0. Hence actually the average value of an AC actually, if you count it, is 0. But you wanted to come up with a single number which is a DC equivalent. That is actually, in that case actually, if this particular circuit is considered, then the positive half cycle actually it is having one impact, and the negative half cycle actually it will have the same impact in the opposite direction. That means if you wanted to compare the positive cycle itself, then actually it will give the DC equivalent for us. Hence actually we consider only half of the waveform and then actually try to calculate the average, so that actually you can come up with a meaningful number, so rather than 0. So that is why actually we calculate the area of only half cycle, and then actually the period actually for this particular half cycle is going to be of pi. So then actually this can be treated as the average value. So this value if you calculate it, so 1 by pi times of integral 0 to pi Vm sin theta d theta. This is the average value. So this is VAVG. And this average value if you want to calculate it, so this is going to be of Vm by pi times of, so integral sin theta. So integral sin, derivative of cos theta is minus sin theta, integral sin theta is minus cos theta. So this is minus cos theta, and then actually upper limit is pi and lower limit is 0. Then this is going to be of minus Vm by pi times of, so minus Vm by pi times of, so this is cos pi is minus 1, and then actually minus cos 0 is actually minus 1. So this is going to be of, so 2 Vm by pi. So this is the average value in the case of a complete waveform. So we have calculated for only half wave, but actually it is applicable for the entire range. So because actually we wanted to compensate the negative. So for that actually, so you have considered only till this particular point, you have calculated the average rather than the complete cycle.